The power of concentration is the only key to the treasure house. The power to concentration is the only key to the treasure house of knowledge. By Swami Vivekananda. What does this mean? If you concentrate more, then only knowledge can be achieved. By Swami Vivekananda. Hi everyone, this is Akshay, Faculty of Mathematics, Vivek Vidya Youth Forum, New Delhi. In this particular video lecture, we will be discussing about nature of fruits and introducing the next part of the chapter, which corresponds to Unit 4. So let's get started with nature of fruits. The quadratic equation is important formula and it is used to find out the roots of the quadratic equation, which is of the standard form ax squared plus bx plus c equals to 0. The advantage of using this quadratic formula to solve the equation compared the other methods of the quadratic formula always works. Compared to other methods of the quadratic formula, this method of quadratic compared to other methods of solving quadratic equations, quadratic formula is a method which always works, no matter how complex the equation is. However complex the equation is, quadratic formula works. And quadratic formula requires finding of square roots of the expression, which is called as the discriminant, we will be discussing right now. And this discriminant is useful, which is used to determine the nature of roots of the equation before even solving the problem. Before even solving the problem, you can find the nature of the roots, whether they are real, whether they are imaginary. And under real only you can find whether the roots, both the roots are same, both the roots are different. So yeah, discriminant of a quadratic formula. A quadratic equation, the discriminant helps us to find the number of real solutions in the quadratic equations. So let me just write few important stuffs on the board. Sorry. I'll take yellow color. So discriminant. Discriminant. Okay. So this discriminant, how can you determine this discriminant? We have standard form ax square plus bx plus c equals to 0. From this standard form, how can you determine the discriminant? So discriminant is given by the formula b square minus 4ac. b square minus 4ac. And this is how we find the discriminant. Now coming to the main topic, what we have is nature of fruits. Using discriminant, how can we find the nature of fruits? So if this discriminant is greater than 0, if you get the discriminant as greater than 0, then we can say roots are real, but they are unequal. If we get d equal to 0, we say roots are real and equal. So real and equal. Roots are real and equal. If the discriminant is less than 0, we say roots are imaginary. I have discussed about this already in the previous sessions also. But I had told also, this is those questions shouldn't have been put under that session, but also they have put over there. So only I had discussed in bits and pieces. Now I will take it properly over here. So yeah. So this is all with it. And now we have something known as quadratic formula. So let me just take the quadratic formula in the next page. So I will put the heading over here as quadratic formula. Put the heading as quadratic formula. Put the heading as quadratic formula. Let me take a white color formula so that it's easy. So we have standard form ax square plus bx plus c equals 0. And we know x is equal to minus b plus or minus root of b square minus 4ac. We have used this in the previous exercise. In the previous unit, we have used this formula divided by 2a. We have used this formula in the previous unit also. And we know that, just a minute, we know that b square minus 4ac is nothing but the discriminant. We can find the solution only if they are greater than or equal to 0. Only if they are greater than or equal to 0, we get the solutions for the quadratic equation. I mean, we get the roots for the quadratic equation. If they are less than 0, roots are imaginary, which are actually not possible for us to find. And we have few relationship between roots and their coefficients. Coefficients and roots can have few relationships. When two roots alpha and beta are given in the question, you can derive the formula alpha beta given in the question. Roots are alpha and beta, which are given in the question. We can derive x square minus sum of the roots into x. Roots into x, and then plus product of roots plus product of roots is equal to 0. Plus product of roots is equal to 0. This is how you can derive the equation. Having known both the roots. Knowing both the roots, you can derive this equation. When the sum of the roots alpha plus beta, alpha plus beta is nothing but equal to minus b by a. Alpha plus beta is nothing but equal to minus b by a. Whereas alpha into beta, the product, alpha into beta is nothing but equal to c by a. Alpha into beta is nothing but equal to c by a. So that's all with this unit. But when you go through the exercise question or the example question, it's only till this part. It's only till over here. I suppose this is given in some other book. So I have added it over here as an additional. You can take this as extra. You can take this as extra. Right. First, we learn about discriminant, how to find the discriminant using the quadratic equation by the formula b square minus 4ac over here. And then later on, quadratic formula we learn. And when is the quadratic formula applicable? In all the cases where discriminant is greater than or equal to 0, it is not applicable when it is less than 0. When it is less than 0, it is not applicable. It's not applicable when it is less than 0. And there is some additional information, that is how to find the equation knowing the roots. So this is actually additional. This won't be asked in your any exams. As far as I know, this won't be asked in any of the exams, but rather for your higher levels, or for more exams like competitive level, like NTSC exam or any competitive Olympiad you are planning to take up, this part is pretty important, which I have written as extra. So you know the roots, you can find the equation by the following methods. And thank you. Thank you. We'll see in the next video.